So, hello and welcome to this session. Today we are here to speak about the latest release of SDC Verifier version 2021.1. My name is Oleg Ishchuk. I am Chief Operating Officer here at SDC Verifier, dealing with all kinds of activities related to planning, strategy, sales, helping with the engineering part of our company. I'm joined here today by Bogdan Melnik, who's leading our software development department. He will back me up and will be able to reply to some complicated questions. I hope we'll have some questions during the sessions. And also Petronek, our marketing manager, is joining us in this session. He will make sure that everything goes smooth. Let me know if the connection is not very good, if we have any questions, and it will help us to have a nice and convenient webinar. So we are going to go through the several slides at the beginning, and then I will jump directly into the presentation. I will show the new features of the program directly in the interface. Everything what is shown today works for all three FEA programs that we are supporting. So for Ansys, for Simcenter Femap, and Simcenter 3D. And as I mentioned, if you will have any questions, don't hesitate to unmute yourself and ask, or type the message into the message box, or we will have questions session in the end. So I see that most of the people are attending this webinar are already familiar with the idea of what is SDC Verifier. So I'm not going to describe once again the idea of the software and why do we develop this. If you're not familiar with SDC and you joined the first time for a session like this, check our YouTube recordings. We have a lot of introductions and previous webinars describing the software. We also have step-by-step tutorials on our website, or you can always contact us and ask for demo or for dedicated presentation. So just a quick reminder, SDC Verifier is an extension to Ansys Femap and Simcenter 3D with the main focus on code checking, verification according to different rules and regulations. We connect to your model, combine the loads, recognize the structural members, do the check and automatic report. And of course, we have an optimization tool to make your, to optimize the design according to the checks. So we are not only saying that the structure is okay or not according to the rules or regulations, but we are also helping you to get the correct design. Okay, so let's start with what's new. First of all, SDC Verifier 2021.1 is supporting the latest releases of Ansys Mechanical 2021 R1 and Simcenter Femap 2021, and Simcenter 3D 21.1 was already supported in previous versions. So we are currently working with all the latest versions of general CAE programs. As you can see, also we are trying to match the numbering. Now all the three programs have similar numbering and we are matching this. So as soon as main FEA players are going to release their next versions, somewhere in the summer, I think it's happening, in several weeks, up to a month, we are usually trying to match with our major release and stick with the same version. So no confusing anymore. The numbering will make sure that the version of SDC Verifier is supporting the latest releases of the FEA software, but nevertheless, we continue to support the earlier versions. So if you still work with Ansys up to 18.2 or Femap, I don't even know, we work still with 10.3, I think. If you have old versions of general FEA, SDC Verifier is still capable to connect to these versions. So as I mentioned, our main focus is the code checking and verification according to rules and regulations. So we will start the new features chapter with new standards. I will just briefly let you know from this list what have we added, and then I'll show you the wizards and the codes themselves in the software. So we have introduced FKM version 6. This is a German standard for stress assessment of components made of steel. We have a static stress check and fatigue check for this standard. We already had version 5, and now we added version 6. I am aware that version 7 is coming soon, but we still couldn't find it published. So since most of the customers have asked us to update, for now we updated for version 6. As soon as we have a released version of 7, we will consider adding this as well. For Eurocode 3, the code that we have already for quite a long period of time, we have added few more cross sections that has been missing for beam member check. So it is a circular and rectangular bars and also T-shapes. We are now working with I-beams, channels, circular and rectangular tubes, and of course there's 3 new cross sections. Then we have DVS 1608, 1612, the code commonly used in railway industry, as well as multiple other industries for aluminum and steel structures for static stress check and fatigue. We had that code before, but now we have also introduced the static stress check. The next new standard is AIJ. It's a Japanese standard working with beam members. We have worked on this standard for quite a long period of time. Now we finally are ready to present it. It supports all kind of cross sections except angular L sections, which are not supported yet. Then we have AS 3990. It is Australian standard, which is developed with the help of our long-term customer and partner EDC Australia. This standard is also working with beam members. I-beams, boxes, circular tubes, C-shapes are supported in this code. We are also having in plans other Australian standards as well as BS standard and so on. And the last in this list is a small update to ESME chapter 8. For the fatigue assessment of pressure vessels. We have added another option there, which is quite important. It's a user input for fatigue penalty factor. So it's a slight modification. And with this list, I would like to go to the window of the software, but first I'd like to add that with all the standards we have introduced, we are currently having, if I'm not wrong, 29 different codes and standards. We are focused on increasing, well, not the amount, well, amount as well, but the quality is first of all for us. So we try to do as much testing as possible before and benchmarking before publishing something. We have, I think, another 18 standards now in the list. Some of them are they are on different stages of development, but if you have any standards or your customers has any standards to comply with and you lack them in SDC Verifier, send us an email. Now is a great time to speak about this. We are going to have a discussion on priorities of this standard. The list for 2021.2 is quite packed. But still, if we got a lot of requests on a certain topics, we would like to raise the priority. So after this meeting or in the end, if you have any standards to add, please let us know. So the library remains the same. I just want to go quickly through the list of the standards we just discussed and show you the wizard, show you some important details of this standard. Well, the most scary one for me personally is FKM 6. It's quite an extensive standard, and after we have added so as you can see, the version 5 is still available, and then we have added version 6. And after we have added to version 6 the static stress check, the list of options looks quite significant. There is plenty of material options to be defined, the material type, kind of material, source of the values, and now some other options has been added with static stress check. We already had some comments in the morning webinar. We are going to sort this option by the check types, so options which are available for necessary for fatigue and the options which are necessary for static stress check. We will also sort separately the material options, then FAT classes, definition, and factors, and so on. So we will make it a bit more readable and in a way to try to fill this data in quickly, because our core idea is automation of routine, and this asks for some time to fill in. So also one of the suggestions of this morning was an option to save the data which is defined for one standard and copy it to another. It is quite complicated because the selection for standard might be different. The material list might vary. So for now, we are thinking on how to implement this, but some possibility to save the defined options should be available soon. And if we're talking about FKM, as I mentioned, we have added a static stress check. And we do have a fatigue analysis with constant amplitude and fatigue analysis with summation. So if you are creating a fatigue group and defining the amount of cycles, you need to create several groups and total amount of cycles, and this will be taken into account in fatigue summation with variable amplitude of stress spectrum. This is quite an extensive code. I want to make a dedicated webinar and the tutorial on our website because the topic is quite broad. So I'm not going to stop very detailed on this, and I hope we will have another learning session soon. Then the Eurocode members, the check remains the same. The only thing we have added is support of other cross sections, so you can check it in the characteristics. Checks as usual. Now it consists of 22 checks, geometrical characteristics at the top, then axial, shear, bending, and combined checks, and the total check in the end. Now supported with circular and rectangular bars and T-shapes. Then we have DVS standard, to which we have added a static stress check for steel, DVS 1612. And one small update in the wizard appeared in here. So we have in previous wizard, as we had this, it's aluminum fatigue and steel fatigue separately. You can include one or both, or whatever you would want. But also for the static stress check, standard requires to put a safety factors defined by the table of the standard. So we added this option. User is able either to get the safety factor from load sets, which he has defined during combining his loads, or use the safety factors from standard, which could be modified. This is quite a handy option. We have been asked about this for several different standards. If you think that this is convenient also to have it, for example, for Eurocode static stress check or any other standard, where you might have a need to use custom safety factors just to make sure that your calculation will go okay, or you want to put some extra safety and not the one that you have used for the load, let us know. Maybe we can add this option also to the other standards. Okay, AIJ, Japanese standard, not much options to define here. The slenderness ratio, characteristic of material, so what kind of material do you have? And then the section build type, rolled or built up, and net area value to reduce in case of you have some removed material. As mentioned, support all kind of cross section except L sections, angular sections, which are not supported yet. Then we have Australian standard, another beam member check. What I wanted to show in here is that the standards that we have, the checks that we have. So we have beam properties and geometry checks, and then the strength checks for the beam members added in this standard. It is currently in beta since we are still working on benchmarking. for this code, but as soon as we finish it together with our customers and partners in Australia, we will release it without a beta tag. So this ends up quite a significant list of new standards in SDC Verifier, which now, if I'm correct, is the list of 29 different codes. Now let's go to the features, new features of the software that has been recently introduced. So let's start with the shape library. If you will go to, I will just zoom it. If you will go to the settings library, in the end you will see the shapes library. And if you will select it, this shape library will open, which brings to the user the interface of overview of all the shapes available. These shapes could be used for the optimization tool. Here we have quite a handy filter, so you could do the filtering by name, like IPE sections, and all the IPE sections filtered. You could do the filter by width or by height, and so on. Then it is possible to create the custom list. Here we have a favorite list. I already have added some sections to this. You could create your own lists which are frequently used in your company. And of course, you can create the custom libraries. We have been asked last autumn by one of our big customers to add the significant amount of different cross sections that they typically use. So we can help you automatically upload a lot of sections if necessary. If you have only one cross section, you could upload it automatically from the list of your property to the library. And so it is nice to see the cross sections that are available, but also the shapes library is used in the optimization tool. So optimization tool, which was shown firstly in version 2020, I will just create quickly one optimization to remind you how the interface of this looks. So in optimization, you are able to create a rule. You select the load, so for example, the maximum overall load group, and then you create the limit parameters from any standards that you have created in your model tree. So for example, we take the Eurocode. From Eurocode, we want to make optimization based on overall check and overall utilization factor parameter. You also can set limits. So for example, you want your optimized beam to be in the range between 0 and 1 for the utilization factor. Press OK. We are going to optimize based on the shape cross-section area. And then here we select the members, which should be optimized as by using our standard rule-based selector. You can select basically anything, properties, materials, beam members, all entities and whatever. Of course, at the beginning, you do the analysis according to the standard, figure out what you would like to optimize. And then, for example, I know that I want to optimize the members from list, like beam members 3, 7, 12, and 13. Then for these members, I could go to the recent selections of the shape, or I could go to the library. So I select this plus button, and here the library is opened. I could go to my favorite shapes and select these shapes to be included for the optimization, or whatever other amount of shapes. Press OK. So based on Eurocode, beam buckling check for overall utilization factor, members 3, 7, 12, and 13 are going to be checked. Isn't it better to replace it with the shapes from the list I have selected? And I press OK. And then I have to run the calculation. Once again, after the calculation is done, we're going to have the list of results, and we're going to have an optimal result. And then you will have this button active, change beam shape in Ansys or in Femap, the software that you use, and optimization automatically changes the cross section to the one that was selected as the optimal result. Okay, just a reminder of what is the optimization and how the shapes library could be used. Now the next thing, we have added the principal stress result category. So, for example, it could be used in tables. If you're creating a new table, for example, for the load set, you're creating a table, and here you had stress, displacement, or all the other output sets. We have also added principal stresses, which are extreme values of the normal stress in the material. So you could select this group and use it, create a table with it. You could also use the principal stresses in custom checks. So if you're writing some check and you need to use by the way, in this way, I'm going to show you how to create a new check. So you create a custom standard, you have 0 checks, you go to add, select custom check, and here you start writing your formulas, parameters, if you want to implement any code yourself. I'll just show you that principal stress parameter is now, result category is now available. You just have to type sprin, if I'm correct, with a dot, and then you can select maximum, minimum, maximum shear. Let's say maximum. So you could use this output in writing formulas as well. Okay, next tool, Connection Finder, which is our first step to make the joint checks of SDC Verifier open. As you might know, we have joint check according to API or ISO interface, but now it works only with circular hollow sections, and the interface is different. The formulas are not completely opened as a standard for all the others checks in SDC Verifier. So this is a sneak peek into what we are actively working in. We are developing the open joint checks, and to have not only circular hollow section to circular hollow section connection, but rectangles, I-beams, and other shapes connections. So if you will go to tools, not the tools, but recognition and connection finder, here you have a tool which helps you to recognize all the connections in your model. So it recognizes the type of connection. If you click on the plus in the list and open the connection, you will see what elements are forming the chord and what are forming the brace, and what are the cross section of these elements, what are the angle, is the joint overlapped, and what are the dimensions of this. This helps us to do the joint checks in the future. But next step to make the joint checks opened is a brace stress tool, which will help you to use these brace stresses even more. So if we to calculate these connections yourself, I mean, so if we go to tools, brace stress, select edit. Here we have a link to our connection finder. Since we have it recognized already, we can close the window and then just press fill table. And for all the connections, you will have a brace stress tool prepared the table. This table, here you could see all the forces and stresses in your connection. And as I just said, we will use it in the future for our joint checks. But you can already see the forces in the elements that are forming the joint, and use this for just, well, checking the values or for building some other calculations. I think that open joint checks for different type of connections are coming in the end of this spring. At the earliest, I think, yeah, in the summer we will be able to present the API joint check for the connections which are not only tube to tube, but the other members as well. Okay, so now let's go to the tables. With the table, there is quite a lot of changes in the tables. I will show you 3 main ones. So if we go to, not the standards, let's do it in a job. Let's go once again to the load set and prepare the expand table on a load set. You do the right click, table, expand extreme. Expand table is making the results on each node and element of the selection. Extreme table is showing the worst result on the selection. So if you do the expand table and then you select, yeah, not to make it too long, let's just select, let's say one beam member, for example, beam member 1, and then fill table. you will have the stress result for all the elements which are included in this beam member. And what we have introduced in this type of tables is the button here in the top right corner, which is a load set content. So you select the member, for example, let's pick the member with the highest compressive stress, which is 197 megapascals, and then we click on this button. We select the stresses for the X direction, and you will see all the content of the individual loads that are forming this load set, and you will see the factors and the values of each load. Of course, the multiplied value and percentage of value that is coming from a certain node, from a certain load. So we notice the element from the member which has highest compressive stress. We want to know which force is causing this stress. We go to this kind of table and we see that 97% of the stress in that member are coming from the force top individual load 3. Then we can see either we want to adjust the cross-section of member, or we want to change the force, or whatever other design update is required. So this is handy to understand the behavior and where the results are coming from. You could also do this for other things like displacement, principal stresses once again, and the rest stuff. Since we are already in this table, I will show one more thing which we have added. It's a default title. So when you are changing the category, so to the principal stress, default title is changing. Default title is based on the options you have used for your table. So if you want to make it extreme, it will be extreme. If you change the selection to all entities, the table will be principal stress load set 1 on all entities, and so on. But you also have a possibility to write your own custom table. So default title is always the same. You can restore default titles always, but you can also use custom names if necessary. Okay, a few more things on the tables. First of all, let's add the other type of table. Let's use a component extreme table. This is a maximum result over selections table. We select this and let's use few members or just a previous selection of one member. I don't know, let's use few. Yeah, let's use like from 1 to 5. Okay, and then we fill this table. So we have the extreme values of stresses in these members, but then if some member is very interested for us, you could click on this member and add the detailed results of this member table. So you click on this and you receive an expand table for beam member number 3. So you don't have a need to go back to create another table. You can quickly preview these results from the component extreme table that you have just created. Okay, and one more update. If we do the flow table, add a table, flow table overloads, and if we do the expand flow table, the parameters have now appeared. You can show different options for the certain for the selection that you have. So once again, let's use recent selection, one beam member, and fill in the table. I have to select the load, overall load group, for example. I'm filling in this table. So I just see the absolute maximum stress. But if I select this option, I want to see on every member, for example, minimum, maximum, and absolute max. I select it like this, and I see minimum, maximum, abs max. If you want to do something even more deep research, you could see all point of interest results. And you select OK, press fill table, and you will have 8 more results, so you could see where it actually comes from, and you have a control over how the table will look. If you just want abs max, you keep it like this, and then you have just for every element the maximum stress. But if you want a detailed analysis or detailed table, you're able to show everything if necessary. Okay, that's it for the updates on tables. And now I'll show a new feature of the report designer. So we go to reports, add report designer full, for example. And here is the report designer of SDC Verifier. A lot of small updates and tweaks has been added, but the most significant one, first of all, it's a report structure. So as you probably know, or I will now inform you, there is two types of report structure in SDC Verifier. There was a possibility to sort everything by loads or by selections. So it meant that if you are creating the expand well, any kind of table or plot via this tab, it will be added and sorted by either loads or selections. So here, for example, we are having results, static structural job, and we have load containers over here. Now it is also possible to have a custom report structure. So if you change this to custom and you convert the load containers into user chapters, you are able to put certain parts only under one container. If you need to group everything in one container, or you need to have a deeper control over the report structure, it's possible to have this one. And now if you are creating something, you are creating it only for a container which is currently selected. If you have finished your modification, you can always get back to the report structure and get back to sorting the results by loads. Another significant change is on the post-processing tab. We have added a peak finder directly into the report structure. So now you can create a peak finder table and plot from the report. You select the peak finder. For those who doesn't know what is a peak finder, it is a tool to show a maximum result from any kind of output. It could be either from load, the stresses, principal stresses, displacement, other things, and or either from the checks you have created. You could use a static stress check, utilization factor, for example. For a certain selection, you could select a load and show the maximum results for a certain criteria. For example, if you want to see the maximum 5% of load of values with highest utilization factor for DVS, this is what I just created. Or you want to see 10 most stressed 10 elements with the highest utilization factor for a static stress check, or you want to see the results in a certain range, you could add this criteria. So let's keep it like this. And also you could add the load set content, something I have showed to you on the expand tables. Now it is also available here and could be added from here. So you add this peak finder table, and here it appeared for the load group, which I have selected, overall load group. The same structure is working with governing loads and free bodies. You can add them now currently directly from the report designer. There is a lot of small improvements in the report designer. I encourage you to try it, to give us a feedback and let us know what are the features that you would like to improve, or what do you like the most. It's important for us to have a feedback on this. Okay, now I am going, well, everything I showed today, I showed on the model in Ansys Mechanical 2021 R1, but now I would like to close this to show you the last one feature we have introduced. I'm not going to save it, and I want to go to Femap. I have a very simple model which represents the weld for two types of meshing. It's a solid model and the plate model. And as you can understand, this is something we are introducing in this version. We start to support not only plates, but also solid element for weld strength check. So I will launch SDC Verifier for Femap. Meanwhile, it's starting. You will also see how to start a new project. So blank window of SDC Verifier. You select new project, get an active model path, check that we have a correct version over here. No need to fill in the project details for now. We press OK. And SDC Verifier is connected to your Femap model. So once again, as I mentioned, we now support the weld strength calculation also for solid welds. But the weld recognition, so if we go to the weld finder still works with plate element or plate to beam connections. We recognize the welds on the shells. So if you will preview now the model, here is the elements that has been defined as welds for this model. But now you are able to add the solid elements to solid welds, sorry, as a manual selection. So you go to add weld. Here is a button to add single weld of solid model. You select it. It's a standard window of adding the weld, so you are adding this. There is a need to select both elements and nodes that are applicable to this weld. So first we select the elements of the welded part. We go over here. We select the welds, for example, we assume that this part is welded, of course. And then we go to select the nodes and we select only these nodes over here. Okay. And then we press calculate, and SDC Verifier recognizes this weld part. You have the length recognized, you have the thickness of it. If you need to make any adjustment, you could do that. And then you can define the weld type. So let's say we think it's going to be the double fillet weld with a thickness of throat thickness of half a thickness. So it's 0.025. We add this. And now we have a weld included. So we have weld 1, which is a plate element weld, and weld 2, which is a solid model. As you know, we use stresses for fatigue calculation. So this approach is only for summarizing the force. So we use forces, summed forces over the weld length for the weld strength calculation. So the solid welds are possible to define now by adding it by hand, and they are available for the calculation of weld strength checks. Okay, and by this, I would like to conclude my part on all the new features we have added. I have covered the biggest one. I have covered the new standards that we have added to the library, the shapes library, the modifications to the tables, connection finder, and brace stress tool. So we are moving in the direction of open joint checks of different types, and we are moving in the direction of solid welds recognition as well, and solid welds checks. So that's it for me. For the new features, I would like to hear from you the questions now or suggestions if you have something you would like to improve or to add in the next versions. This is a great time to discuss these options. We still have 5 minutes. So Petro, do we have any questions in the chat box?
No, we don't have any questions.
Okay. Anybody else, if you have any questions, of course, if you want to discuss something in private, you could always send me an email or give me a call after this session. We had recently in the morning, we had few questions. So first of all, it was on how do we handle fatigue with solids? As I mentioned, for now, we only have weld strength check for solid welds, but we are, this is our goal. We are also working on that one. And then the other question was for FKM standard. People were asking, is it possible to automate this somehow? Is it possible to avoid filling all the details by hand? So we will add a possibility to load a standard configuration, at least for some parameters which are typical. Also, I will see if maybe it is also possible to define the material type from the property name button. Maybe this is something for interesting for us. If you name the property properly in your FEA program, if you will, for example, write stainless steel or forging steel, that SDC Verifier understand the type of steel from the material name. This is also something for us to improve on. If you don't have any further questions, I would like to thank you for attending this session. We worked hard to bring this version to you, so I encourage you to install it and try it, come up with the suggestions for the improvement. We also have a lot of requests from our customer on the weld finder improvement. I think this is something we are going to work on in the future to do the grouping of the weld, possible renaming of the multiple welds, and of course we will continue to work on the solid weld recognition. This will require some quality of the meshing from the user, but I hope it will be. I think, Bogdan, correct me if I'm wrong, if it's a tetrahedral mesh and if it's a straight line, it's possible to recognize it already or not?
Not yet, only manually.
Only manually, but
yeah.
If somebody will do really rectangular, nice bricks mesh, it's not a problem for us to define this, I think.
Yeah.
Okay. At this point, once again, thank you and have a great rest of the day. I hope to speak to you soon. Bye-bye.
Bye. Thank you.
Thank you.